Chapter 5, Radians. Lesson 1, Radian Measure. You've encountered angles in degrees before, with 1 degree being 1 over 360 of a full circle. Radians are another unit for angles that can be simpler to use sometimes, and they're necessary for differentiation, integration, and other things. 1 radian, written as 1 rad or radian, is the angle that's created in a circle from the center if you placed its radius, r, onto the circumference. So if this arc length was r, this would be r as well. This angle here, theta would be 1 radian. 2 pi radians would make a full circle because the circumference of a circle is 2 pi r. So 2 pi radians is equal to 360 degrees. Pi radians is 180 degrees. And pi over 2, so 1 radian would be 180 degrees over pi. And this is how you could convert them. Let's do an example. Let's convert 7 pi over 8 radians and 4 pi over 15 radians into degrees, and then 150 degrees and 110 degrees into radians in terms of pi. For part A, to convert radians to degrees, we just multiply by 180 degrees over pi. And so this will be 157.5 degrees. For B, we do the same thing. 4 pi over 15 times 180 degrees over pi is 48 degrees. Part C, we do the opposite from going from radians to degrees. So we do 150 multiply the opposite. Instead of 180 degrees over pi, it will be pi over 180. And so this will be 5 pi over 6 radians. Part D, we do the same thing. 110 degrees times pi over 180 degrees is 11 pi over 18 radians. Some radian angles are important to remember. So 30 degrees will be pi over 6 radians, 45 degrees will be pi over 4, 60 degrees will be pi over 3, 90 degrees will be pi over 2, and from before we saw 180 is pi and 360 is 2 pi. You can find these by using a scale from 360 to 2 pi or 180 to pi. Let's do another example. Let's find the sine of 0.3 radians, cos of pi radians, and tan of 2 radians, giving answers to 2dp when necessary. For part A, you can use your calculator for all of these. Sine of 0.3 radians, when you put your calculator into radians mode, will give you 0.30 to 2dp. For B, cos of pi radians on your calculator will be equal to -1. Part C, tan of 2 radians is equal to minus 2.19 to 2dp if you use your calculator again. Let's do another example. Let's sketch the graph of y equals sine x for 0 is less than equal to x, which is less than equal to 2 pi. When the domain here is given in terms of pi, you can assume that it means in radians. So let's draw our axes as follows. So this will be x, this will be y, 0. A sine graph usually looks like this, where this will be 2 pi, this will be pi, that's 0. It goes from -1 to 1, where this will be pi over 2, and this will be 3 pi over 2. You'll need to know some of the exact values for trig ratios of angles in radians. The sine of pi over 6 is the same as sine of 30 degrees, which is a half. Cos will be √3 over 2, and tan will be 1 over √3, which is the same as √3 over 3. Pi over 3 is 60 degrees, so sine of pi over 3 will be √3 over 2, cos of pi over 3 will be a half, tan of pi over 3 will be √3. Pi over 4 is the same as 45 degrees, so sine of pi over 4 will be 1 over √2, which is the same as √2 over 2. Cos of pi over 4 is 1 over √2, which is √2 over 2, and tan of pi over 4 is just 1. You'll also need to understand some rules that will allow you to find sine, cos, or tan of positive or negative angles in radians by using the corresponding acute angle with the x-axis. If you look at the cast diagram, we can draw the angles theta, pi minus theta, pi plus theta and 2 pi minus theta. So for the angle pi minus theta, we can see that the cos of the angle is just this length here. Because this length is cos theta, we can see that this is positive, and this is just the negative version of this. So the cos of pi minus theta is equal to minus cos theta. We can see that the cos of pi plus theta is the exact same thing. It's the same cos, but in the negative direction. So the cos of pi plus theta is minus cos theta also. For 2 pi minus theta, we can see that the cos is the exact same. It's just a positive. So the cos of 2 pi minus theta is equal to cos theta. For sine of pi minus theta, we can see that sine is just a y value. So the height of this is the exact same. This is positive and this is positive. So the sine of pi minus theta is the exact same as sine theta. For pi plus theta, we can see that the height here is positive, but the height here is negative. So sine of pi plus theta is equal to minus sine theta. For 2 pi minus theta, we can see that the height here is positive, but the height here is negative. So the sine of 2 pi minus theta is again minus sine theta. Tan theta is the gradient of the line. So for pi minus theta, we can see that the gradient here is the negative version of the gradient here. So the tan of pi minus theta is equal to minus tan theta. For pi plus theta, we can see that the gradient here is positive and the gradient here is positive. It's the same gradient because it's a straight line. So the tan of pi plus theta is equal to tan theta. It's the same. For 2 pi minus theta, we can see it's the exact same as when it was pi minus theta. It's a negative gradient instead of a positive gradient. So the tan of 2 pi minus theta is equal to minus tan theta. And you'll be expected to know how to use these rules. Let's do one more example. Let's find the exact values of A, cos of 4 pi over 3, and B, sine of negative 7 pi over 6. For part A, if we draw the diagram showing the angle 4 pi over 3, we can see that cos of 4 pi over 3 is the exact same as cos of pi plus pi over 3. And so using the rules that we did before, it's going to be equal to minus cos of pi over 3. And we know cos of pi over 3 is a half. So therefore the cos of 4 pi over 3 is going to be negative a half. For part B, if we draw the same diagram again, but this time for negative 7 pi over 6, so we go in the clockwise direction instead of anti-clockwise, we can see that it's going to be equal to the angle of 5 pi over 6. So the sine of negative 7 pi over 6 is equal to the sine of 5 pi over 6. Now, 5 pi over 6 is the same thing as pi minus pi over 6. And using the rules that we did before, sine of pi minus theta is sine theta. So this is going to be equal to sine of pi over 6, which is just equal to a half. And that is about the gist of it.